Thank you so much, and thank you for the nice introduction. Happy to be talking here at the London Calling event. My conflict of interests. So urinary tract infections are one of the most common infections across the world, affecting over 400 million people, which leads to 1.6 billion antibiotic doses every year to people across the world. The current diagnostics methods I can see on the screen behind me takes somewhere between 2 to 4 to 5 days. So from sample collection to culture to the pathogen identification, and then because of antimicrobial resistance testing. UTI is difficult to diagnose in real time because of low number of bacterial abundance. Usually, CFUs of 10 to the power of 3 is considered as clinically relevant urinary tract infections. A lot of the UTIs are polymicrobial, meaning to say there are multiple bacteria that could cause the infection. Also, the urinary tract has its own microbiota, so sometimes it's difficult to differentiate between the pathogen and the normal microbiota of the urinary tract. Some of the pathogens are slow growing, so it takes more time for them to be cultured and then get the identification. Plus, urine is a complex media which has salts, urea, and other chemicals that make it difficult for DNA extraction. Like I said, there are over 400 million cases of UTI every year, and the largest use of antibiotics is in urinary tract infections. We did, what I'll present today is 3 different phases of the clinical study. It's much more advanced to what we actually put in the abstract. So in the first phase, we wanted to check whether it is possible to sequence directly from urine. What we did was to take healthy urine samples spiked with pathogens that were relevant for urinary tract infections, and then did DNA extraction and metagenomics. This paper was published last year. And so what we found that with spiked samples and doing blood extraction with different kits, followed by nanopore sequencing, we were able to give information about the pathogen ID, the antimicrobial resistance gene, in somewhere around 5 to 6 hours. But this was, keep in mind, only on spiked samples. Luckily, we have a very good collaboration with the European Society for Infection and Urology, which is one of the policymakers for urinary tract infections. And together with them, we did a clinical study at the University Clinicum in Gießen in Germany. So in phase 2, what we did, we took patient urine samples directly from the urology ward and tested 11 different DNA extraction methods. Out of this, 8 of the methods were in-house developed and 3 were commercial methods. So we wanted to test our in-house methods against commercial methods for DNA extraction and then do nanopore sequencing. This was done on a data set of 77 samples. It's currently under review with Nature Communications. But it's also, this paper is actually also on medRxiv, so happy to, please have a look. So what we found was that there was 99% accuracy when it came to the pathogen detection. And out of this, we had 50 samples that were tested on one single method that was optimized. And as you can see here in the slide behind me, green are those where our results are concordant with the clinical routine. Red is that where the clinical routine finds it, but we don't. So there's only one bacteria in one sample that we didn't find. We found one, but we did not find the other. Orange is the one that we found with metagenomics, but the clinical routine did not find. So as you can see, these are very complicated cases because a number of them, more than 50% of them, had polymicrobial infection, that is more than one pathogen that was responsible. So you can ask whether the one that we found with metagenomics, were they really present in the sample or not? So what we did, so all those that were in orange, we did a follow-up study with the sample with a vivolytic method that the hospital in Gießen had and PCR, and we were able to validate the presence of those different pathogens in the clinical samples, which is a good validation to make sure that what we are not over-predicting, that we are predicting the right pathogens. It's very important. So that was the easier part. How about the antimicrobial resistance? So when it comes to the detection, so we did a genotype to phenotype relation. So we had the AST data from the clinical routine, and we had the genotypic data. We tried to match it to that, and we got 90% accuracy for the AST, so which antibiotic resistance mechanisms are present in the samples. We work quite well. So this is a panel of the different antibiotics that were tested. So this is the panel that the hospital in Gießen uses for treating UTIs. So we work quite well, but there are certain cases of antibiotics where our predictions need to be improved, like the trimethoprim. Some Cipro predictions also need to be improved, and that is what we are currently working on. So in short, from when the sample, so when we got the sample, to when we were able to give the information about the pathogen and the right antibiotic, we could give it in around 4 hours of time. That is a big, cutting short the time from what is currently to 2 to 4 days to 4 hours, and could certainly help in better clinical management of urinary tract infections. Another thing that we found while doing the study, so different hospitals use different methods. So for example, in Gießen, flow cytometry method is used at the urology ward before the sample is sent to the clinical microbiology. And we were able to find a correlation between the number of cells, the bacterial cells, to culture positivity. So with a pretty decent ROC. Also, we wanted to check, do we need to sequence everything? Because sequencing is costly. So we wanted to check whether the DNA yield could give information about culture positivity. So we found a decent correlation of a little over 220 nanograms that said, okay, samples above that turned out to be culture positive, and below that were usually culture negative with a 0.87 ROC. So what about the cost effectiveness? So the different kits that were tested, they cost different cost, whereas our method is slightly cheaper, which is an in-house developed method. This is all including the DNA extraction and the sequencing, and the sequencing cost is done on 24 samples. Obviously, if you do more multiplexing, you can reduce this cost. However, if you don't need it to, if in those cases where the DNA yield was lesser and where we said that we don't need to do the sequencing, the cost of method comes down drastically. So you don't need to sequence everything if you don't expect positivity in your samples. So we are currently in the process of validating this method further to more than 300 patient samples, again in Gießen, following the optimized method that we have developed. We have currently tested 278 samples. Out of this, some based on flow cytometry, we could say that whatever we had predicted, the number of bacterial cells still holds. In over 221 samples, we extracted the DNA. And out of this 221, we have sequenced 128 because the rest had a bacterial load that was less than the threshold that we had set for culture negativity. So it's basically a staggered approach. So we have now 128 samples that we have sequenced, and the current results basically matches the previous results quite well. So again, green shows for concordant to the clinical routine, orange shows that what we found in metagenomics, and red is what we make. So we are getting a 99% accuracy when it comes to the pathogen ID. And 91% accuracy, slightly better with larger numbers because we have worked a little bit more on the prediction method for genotype to phenotypes, 91% accuracy when it comes to the AST. So what the future is, so what we are, if I can conclude and say what the future plans are, so we are getting a 4-hour turnaround time in most cases from sample to the information on which antibiotic should be used. We are getting 99% accuracy for pathogen ID, 91% for AST. This will help in prudent antibiotic use. Like I said, 1.6 billion doses of antibiotics are used only for urinary tract infections. We can further reduce the cost if we take into account the flow cytometry data and how much DNA yield that you're getting to show which is culture positivity and negativity. So we have several studies planned. We have ethical approval to do a study now in Norway. We have ethical approval to do the study in All India Institute of Medical Sciences in Delhi. We have ethical approval now to do the study in University of Southampton. And I'm really proud that in the latest project that we have got, WHO has said that if the method works, WHO will help us to spread the method across the regions in Asia Pacific and the world. Thank you.